let's apply the concept of rolling resistance, grade resistance, and total resistance to the problem one. A wheel tractor scraper weighing 100 tons is being operated on a whole road with a tire penetration of 2 inches. What is the total resistance and effective grade? When, first scenario, your scraper is ascending a slope of 5%. So in this case, it go uphill with the slope, geometrical slope 5%. And then the scraper is descending a slope of the 5%. So it go downhill. That is the second scenario. And with that, we can apply the concept we just learned to this problem. So let's go to the A, ascending slope. So we have two components, total resistance. We have rolling resistance and grade resistance. Calculate them separately, add them, and then we also apply the effective grade percent that consider both rolling and grade to find out the effective grade in percent. So let's do that here. The first one, as you can see, the rolling, first one on way, rolling resistance factor. And in this case, they give us the penetration. So you can apply the equation from here. If they give you the material or the surface, so you can go to table 4.1 or slide number 2, and it's also available on the reference for midterm exam. So everything should be available. In this case, they give penetration, so you can apply the equation and the unit. And you can see it will be pound per ton of the weight of the equipment, and it equal to 40 plus 30 times inch of penetration. So it you can see here give you 2 inches, so it will be 2 inch, and that from this equation we have there, and from that we get this equal to that's equal to 100 unit is pound per ton of the equipment. So because it's pound per ton, then in this case the equipment is 100 ton. So we can have the rolling resistance in that case. And it should be equal to the rolling resistance factor, 100 pound per ton, time, how many tons they have, time 100 ton of the equipment, in this case wrapper. And from that we can have 10,000, and ton cancel out, so 10,000 pounds. So the rolling resistance given that equipment and the material on the surface, the resistance equivalent to 10,000 pounds, equivalent to 10,000 pounds. And the second one we want to determine is the grade resistance. So the slope, basically, how to consider the resistance due to slope. So that grade resistance. And grade resistance, we have equation already. Grade resistance is equal to the 100 vehicle weight times the grade resistance factor, or vehicle weight times grade. Okay, and the grade resistance factor equal to 20 times grade percent. So first we start with the grade resistance factor. And from that equation here, you have 20 times grade percent. So we have it 20 times grade percent equal to, and that I make down here, it go ascending slope. So as you can see, it go up, so it will be positive in that case. So we have that one is positive 5% for the first scenarios. So it will be here ascending positive. And then of course the next one it will be negative if you have. So from that we can have the this resistance factor it equal to 100, and it unit it will be power per ton of equipment, power per ton. And then we can have grade resistance. It equal to the grade resistance factor time vehicle weight 100. Again, we cancel out the ton, so you will get also 10,000 pound, 10,000 pounds. So with those two, and the total resistance equal to rolling resistance plus grade resistance. So you can have that. Finally, I can have the total resistance equal to grade resistance and rolling resistance. Rolling resistance 10,000 pounds plus 10,000 pounds for the rolling. So we have 20,000 pounds total resistance, and that should be the first answer. And then the effective grade that combine both should equal to grade percent, and in this case the slope 5% uphill ascending, so it will be plus 5%. And then add rolling resistance factor divided by 20. Rolling resistance factor we find out it 100, so we have it 100 divided by 20, so it will be 5. So total, as you can see, effective grade 10%. What does that mean? It means that 5% contribute due to the slope and 5% due to the rolling resistance. So combined, the effective grade is 10%. So equivalently, they go up 10% if we combine both. So that is the number one. And of course, B, scenario B, descending, it will be quicker. Then we can move on. The first one, as you can see, grade resistance. Regardless of go up or down, rolling resistance remain unchanged, but grade resistance, it depends on go up or down, right? So it will be 100 grade resistance factor 100 time 20. So let me rewrite here. It will be grade resistance factor, so it will be 100 time 100 here. So be 100 the weight time 20 for the grade resistance factor time the grade percent, and it going down, so 5%. Let me write in green 5% because descending. So from that we will have that equal to negative 10 pounds. Negative, as you can see, it less resistance because go downhill. So from there we can have total resistance in this scenario it equal to rolling resistance remain unchanged regardless of go uphill or downhill plus minus 10,000 because go downhill, and then as you can see 0 pound. So in this case no resistance because the way that go down equivalent to the resistance due to the rolling. From that, you can guess what should be the effective grade in this case. And effective grade is equal to slope, geometrical slope of the surface, negative 5% going down. Rolling resistance factor, 100 pound per ton, divided by 20. So 5 minus 5, so it will be 0%. What does that mean? It's equivalent to the equipment go on the level, horizontal in that descending. So that done for problem 1.